Who's Jon Hirschtick, who is technology pioneer, leading entrepreneur in CAD industry, and of course, as you could imagine, as one of the most prominent figures in CAD history, his CV is full of accomplishments, so I'll just name a few before we start. He holds bachelor's and master's degree in mechanical engineering from MIT. He spent most of his career on building software products for hardware design. He's founder and former CEO of very successful CAD companies like SolidWorks, which was acquired by the Dassault Systems, and Onshape, now part of PTC, and currently he fulfills the role of Chief Evangelist at PTC. In addition to his professional achievements, he's also known for being involved in MIT Blackjack team. So for all these reasons, but also for many more, I would kindly ask you to welcome our keynote speaker, Jon Hirschtick. So, Jon Hirschtick, the floor is yours.
Thank you. So I have spent 43 years building CAD software. 43 years trying to figure out how to use computers to improve product development process and the lives of the people who do it. And sometimes people will say to me, you know, what was it like in the early days? What was it like when you were just getting started? And my answer is always the same. Today, now, is still the early days. And today, now, I feel like we're just getting started. Because even though we've been building these things for decades, there's so much more we can do. This was true years ago, and it's even more true today as we together are on the edge of the beginning of this exciting world of AI, modern AI, applied to product development. So in this talk, what I want to do is take a perspective view and say, what can we zoom out? If this were a CAD command, zoom out and take a perspective view and look at AI in product development in the largest possible space. Here, well, we're gonna need help here. Yeah, I'll just go on. So in the broadest possible view, where have we been? Where are we now? Where are we going? And I have a few key points I want to emphasize here. One is that CAD has been around even before I got into it. It's been around for about 60 years, decades of development of CAD, and research has played a key role. People like you, research played a key role. AI presents this enormous promise, modern AI I'll call it, because there was AI years ago, presents this enormous promise for product design, huge potential. However, today, right now, if you go into industry, and I spend a lot of time in industry with real users, very low levels of usage, actually, of AI yet. But I think that's going to change. And there's tons of exciting research, and I'm going to show you some of that in a moment. And it's research across a wide range of application areas. I've seen many people here talking about their work. I'm going to show you some of my own. But it's much broader than just the kind of nominal AI imaginative task of saying, go design this for me. It's much broader than that. CAM and PDM and rendering and simulation are all fertile areas for AI thinking. And then finally, I want to talk to you about what do I think we should be thinking about as we enter this AI era? What considerations do we, the tool builders and researchers of our industry, what do we need to be thinking about? First, though, a disclaimer about me. Everything I'm going to tell you is as far as I know. I'm not an AI researcher, and I'm not an AI developer. Well, I did a little bit back in the old generation of AI, back in the 80s, but not today. But I do build real tools, as you know. And so I'll just say in advance, excuse me for any omissions or errors that I make. I'm just trying to communicate some points. I know I'm leaving a lot of information out of this talk that I could have added. So let's start by going back in time to the past a little bit, because I think it's fun to think about how we got where we are with computers in general. 1963, Ivan Sutherland writes a PhD thesis called Sketchpad. How many of you have seen or heard of this amazing work? Okay, some, but not many. Incredible vision. This is 1963, and he builds what may be the world's first CAD system, and it's a research project. And he builds this in an era where there is no interactive computer use, there is no graphics toolkit, there is no hardware for interacting with the computer. He has to invent all of that just to fulfill his vision for how computers could help product developers. And wow, did he have vision. Check out this YouTube video. I'm not going to play it here, but by the way, if you like any of the links here in my talk, I have a lot of links to other material. Don't worry about capturing it now because the slides will be available or a recording of this, and you'll be able to reference anything I show here. And feel free to punch in and watch the video while I'm talking. I know you're going to do it anyway, so I'm just saying don't feel uncomfortable. It's okay with me, okay? So fascinating video. And you'll see he imagined not just CAD, but a workstation, a light pen, even constraint-based sketching, a hallmark of modern CAD. This is 1963. Incredible vision, incredible research, structural analysis, all part of Sutherland's work. I had the opportunity to meet Ivan Sutherland, and this was 50 years after he wrote his thesis. I sought him out. I wanted to meet him. I wanted to shake his hand and talk to him, thank him for what he did. He was still doing research work when this photo was taken, not in CAD anymore, and I got to hold in my hand this board. This is a board from that computer that was used in Sketchpad, and it has 8 transistors, about the size of my iPhone that has 8 billion transistors. So technology marches on. Now we move to the 1970s, research again leading the way and thinking about solid modeling. As great as Sutherland's work was, it didn't talk about solid modeling, it talked about wireframe modeling. This work is one of many around the world. University of Cambridge, BREP solid modeling. The first CAD systems appear, computer vision, Applicon, big computers, okay? I don't know if anyone's ever used these, museum pieces now. Good at wireframe modeling, not good at solid modeling. Many people tried to make solid modeling work out of the lab. None of the products worked very well. And then in the 80s, more research. Dave Gossard at MIT, he was my professor. I was lucky enough to work with Gossard. In his lab, all these different topics in CAD were being worked on, a little bit of AI too. Another fantastic YouTube video, only a minute and a half long. Encourage you to watch it. By the way, I was standing in the room when that video was made. Okay, I probably set up the demo for him. I was a grad student, and that would have been my job to get it all ready and shoot the video. And that, out of this environment of research and many other CAD systems, 2 key CAD products come out in the 80s. AutoCAD, which put 2D CAD on a DOS PC, okay? And then, drumroll moment for solid modeling, about 1987, PTC introduces Pro Engineer. How many people have used Pro Engineer, know what it is? When I saw Pro Engineer, my jaw dropped. It was such an amazing product because we had worked on all these concepts in the research lab, but none of the products really worked until Pro Engineer. By the way, I used to say exactly the same thing before I worked at PTC, where I work now, But when I was at SolidWorks, I would give a lot of credit to Pro Engineer because this paradigm of sketch, extrude, fillet, shell, this is the way all the CAD systems work. If you use SolidWorks, if you use Onshape, CATIA, NX, they all work this way. PTC, Pro Engineer. Today the product's called Creo. It's still an amazing product. But I saw that and I thought, wow, PTC's modeling is great, but it's too hard to use and too expensive. And I saw these Windows PCs coming along, and I saw AutoCAD's price was much more attractive. And so I founded SolidWorks with this vision of PTC's 3D, Windows platform, AutoCAD low price. This is a picture of some of the SolidWorks founding team here. That's me in the necktie at the top there. And this SolidWorks, how many of you have used SolidWorks? Okay, quite a few. Great, happy to hear that. We're glad we built it. It helped a lot of things. However, I stayed at SolidWorks almost 20 years. And I saw our customers having all these problems with installing software and configuring computers and license codes and service packs. And that was the easy stuff. The harder problem was the data and hundreds or thousands of files and copying all over the place. And PDM systems, someone came up to me earlier who had built PDM systems decades ago. And I saw what was happening with cloud and cloud native systems, and I said, hey, we can solve so many problems that the SolidWorks customers have, but we need to build a new system. And build it we did, and that's Onshape. It's still the first and only real cloud native CAD and PDM system. You can think of it like SolidWorks meets Google Docs meets GitHub, for those of you who've used it. How many of you have used Onshape? Okay, awesome, thank you. I hope all these things are valuable to you, but we have a lot of benefits here in it. So the last thing I'm going to show you in sort of the pre-AI generation is right at the seam between regular CAD and AI is spatial computing, augmented reality. I have a video here, and I don't know if we can roll the video. If not, that's okay. The video would show you through the lens of an Apple Vision Pro a user manipulating parts in an assembly, okay? And that experience, I think, is going to go hand in hand with the AI generation for certain applications, not all. And in fact, by the way, we have an Onshape application shipping on Apple Vision Pro. It was shipping the day the Vision Pro came out. So for those of you, and I saw many of you are experimenting with AR, you should check out the Onshape Vision app. It's a commercially shipping app, and it's a full client for live CAD data. You can collaboratively edit data while someone's looking at it through the Vision Pro. It's not just a viewer, it's live editing, okay, and collaborative editing. Really very cool, we're very excited about. Okay, now I finally get to the AI part, which is probably what you're most interested in. I take my vision for AI and design from a lot of places, but one of them is Iron Man, the movie. How many of you saw the Iron Man movie? Okay, why am I bringing up Iron Man? When I saw that movie, that was another jaw-dropping moment because it's got Tony Stark, the character, and he's talking with an AI assistant, conversational AI. He's using augmented reality and hand gestures to design. I found that to be a powerful vision, and I think we're getting closer to it coming true. I'm not saying it has to be like Iron Man, but it's a pretty interesting moment in the movie, and again, I'd encourage you to watch the video. So what is in use today? AI, if I go into a customer, what can I find? Customer, an end user, not research lab, but end user. What's being used today? And I'll show you a wide range of examples. None of them are being used all that frequently. Maybe 1% of all customers use any of this right now, but it's interesting to see it actually used in industry. Simulation surrogates. How many of you have heard of this? Gosh, I hadn't until about a year ago. Really cool. You take huge numerical simulations that might take hours or days to run. You train an AI system to be a surrogate for that simulation, and it runs up to 1,000 times faster, making optimization possible. 2 companies doing this, Neural Concept and Physics AI. Again, you can find that on the web. Here's an example of a simulation surrogate. Highly nonlinear multiphysics simulation of a high-performance car racing tire. It used to take 15 hours, now it takes 1 second. Very powerful and being used by real customers on many examples. Generative design, I'm going to start with the traditional kind, not generative AI, but in this case you give a boundary of the part you want and tell it some loading conditions, and the system will generate a shape. I assume many of you are familiar with this, some of you may even use it. You get these organic looking shapes like the blue part shown here. This is being used as part of several CAD systems, standalone products as well. The question is, do you consider this AI? Well, I do. And some people say to me, I don't. So to settle the dispute, I asked an expert, I asked ChatGPT if we could consider this kind of generative real AI, and the answer I got was yes, you can consider it real AI. So I feel good now that ChatGPT sort of backs my view. Here's another example. This company, Viscom, takes sketches and turns them into design concepts in the image space only. So you take a sketch and you say, orange and black controller, Nintendo-like, and it gives you this. Again, just a bitmap image. You can also take an image, in this case, of a shoe and outline the blue area and say, I'd like you to refine just this area of the design, make it look more like an Adidas shoe, and it'll give you the result. Pretty cool, and again, being used in real industry. Cloud NC, this isn't a CAM system, but rather an AI assistant for a CAM system, say Mastercam, and it drives the CAM system, create programs claiming to go from what takes a human hours, it will do in minutes, and they show real parts of interest, and I've talked to people who've used it who say this really does work. So, really cool. This is Ada IQ. This is a spin-off of research from Northeastern University, Tucker Anthony, professor here. They take product reviews, and I saw a talk here with people working with product reviews online, generate these comparison spider webs of brand attributes, and will also synthesize new designs, again in the image space for shoes that would be predetermined to be really good for consumer taste, for performance or stability or color. Very interesting work in a commercial product. DraftAid, they take a 3D model and automatically generate drawings like this one. Reasonably complicated, suggests real use, and I have heard of people starting to use these. I think the most widely used tool today in product development, though, is just general AI tools, using ChatGPT to summarize things, or ask for advice, or look at a spec sheet, look through spec sheets and things. I'm seeing people talk about using AI imaging tools to do things like resolution enhancement without even making a big deal out of it. They'll just matter-of-factly say, oh yeah, I used a resolution enhancer to improve the image. So that's a cool thing. This is far and away the #1 use of AI in product development. Okay, so very little, maybe 1 out of 100 companies using anything besides ChatGPT today, but I think it's going to grow. But a fascinating range of commercially shipping applications and an even broader range of research. Now, I'm only going to scratch the surface in reviewing some research projects that I happen to know of that I think are interesting, very broad range. This paper here, and again, all the references are in my slides, and the recording of this talk you can find, or you can even grab the number from the slides and go to archive here. This paper here from a group from University of Washington, MIT, and Harvard, they talk about how can large language models help humans. It's a really big paper, like 100 pages, with all kinds of examples, including using text to generate a model of, say, a bookcase, optimize it, parameterize it, even source it. And that video is online. You can watch the video, again, if you're interested. It's a great little video. Encourage you to watch the video. Another interesting project, this is a startup company, but I call it research because it's not shipping yet, to my knowledge. This is one of the many efforts I've seen to generate geometry from text prompts. So you say, hey, give me a block that's this big with a 3x3 array of holes, and it will generate it. And this is very, very interesting work. However, it's still very simple geometry, and all the projects I've seen like it are still relatively simple. That's not a knock on it. I'm not saying don't do it. I'm just saying here's where we are and here's where we're not. This has to become usable for more complex geometries, but it's quite fascinating to see it generate shapes and load them into a CAD system. In this case, Onshape, because it happens to be on their website and it happens to be someone I know, but I think it would work with other CAD systems as well. So that's probably an application you knew about. Here's one you may not know about. This is automatic assembly. So in this case, everyone knows you take parts in a CAD system and assemble them with mating conditions, right? Almost everyone here gave me the feeling you've used CAD. You've probably done that. This attempts to do it automatically by training on an AI data set. And so you go from this bucket of parts to this finished assembly, and the results are actually very encouraging to automatically do this. By the way, this team is also from University of Washington and Columbia, but also has people from Adobe and someone from PTC on our Onshape team. So our Onshape team, we're not shipping a lot of AI products yet, but our team is working on research papers. Okay, so you'll see in the literature, you'll see PTC employees like Ilya here participating in these research papers. Computer-aided design as language, this is Google DeepMind, and again, an Onshape team member working on this project. And this is aimed at sketching. They took millions of sketches. You might say, where do you get millions of real sketches? Hold that thought. I'll get to that. Okay, millions of real sketches, trained a system, represented it so they could do prediction. They could potentially automatically generate sketches or auto-complete them, is the potential of this kind of work. An area you may be surprised to know about is work in the nuts and bolts, the nitty-gritty of CAD geometry. Okay, this is a project, well, by the way, something we spend a lot of time on, so we're very motivated, and not surprisingly, there's a couple of Onshapers worked on this. This problem is you take a dumb solid out of one CAD system, import it into another. Maybe some of you have done this. If not, you'll kind of get the idea. And you reference surfaces on it to build new geometry. Now the original solid changes, you re-import it. How do you figure out where the references go? Okay, Onshape does this already. SolidWorks does this already. Most CAD systems do it already. The question is, could we do it better and faster with AI? And the answer is, not quite yet, but very promising. And so a rich area for AI for us is the details of geometry. You know, could we get AI-assisted filleting? Could we get AI-assisted surface creation? Okay, this has big payoff for because users spend a lot of time doing that. This is a fascinating project out of the Decode lab at MIT. Lyle Regenwetter and colleagues. This is multi-counterfactual optimization. So it's optimization, in this case of a bicycle, which can include traditional optimization, like, hey, make this frame lightweight and strong, but also can bring in simultaneously optimization goals like make the bicycle look like this image that I'm giving you, and also a text prompt, like can you make it look a little like a black cyberpunk style bike, whatever a cyberpunk style bike is. I don't happen to know that, but the AI bot does, and it will generate an optimized model. I find this fascinating and probably fairly close to being useful for real users. There's a website, again, the link is in the presentation slides, a website where you can go and try this out yourself. Another very cool product out of that MIT lab is linkage synthesis. First, they generated 100 million planar linkages. Anyone ever design a linkage by hand? Yeah, not particularly easy. I see some smiles out there, right? There's no easy, obvious way to do it, right? It's just kind of trial and error. Well, they're working on this with AI, trained it with 100 million, and now there's a result where you can give it a path, like say the letters IBM, and it will synthesize one linkage that will draw that path. Anyone want to try doing that by hand? Not me, okay? It's a tough problem. And that's a single motor driving the linkage. All right, so I think this is very encouraging. Okay, not everyone is designing linkages every day, but this could represent a class of very labor-intensive design problems that might yield AI approaches. Oh, sorry to stand in front of you. This is a really interesting one. I talked earlier about numerically based generative design, right? The blue part I showed you earlier. I think you're probably all familiar with it. This is an attempt to use diffusion optimization to accomplish the same goal in a very different way. So I think it is the bottom is sort of a traditional approach, and the top row is the diffusion generated approach. So there's essentially, as I understand it, again, I already told you I'm no expert, but you're taking the technology of image generation that we're all familiar with from AI and trying to repurpose it in a way for generative design for structural shapes, in this case 2D cross sections, and it works shockingly well. So this could lead us to better ways of doing even the type of generative that you know about. And I'll show you an experiment consider this from like Onshape Labs. This is not shipping. I can get into why if anyone wants to know. We can do that in Q&A. I don't want to get too distracted. But this is probably nothing you'll be surprised at. You take a CAD model and you just give it a prompt. It should be stainless steel on a wooden workbench, and you run it and you get a nice image. You know, this is the kind of thing we're experimenting with. We, of course, have traditional rendering in Onshape where you can do photorealistic rendering, setting up the problem and all that. We can talk about the differences there. And finally, in the geometry, this is my last geometry generation project. This is a system out of OpenAI research that generates 3D objects as point clouds. Okay, so these objects here are generated from text prompts, and they're point cloud geometry. Very coarse objects, but a surprisingly rich range of descriptions, like a vase of purple flowers, or a red coffee mug, and it generates it. So this is interesting work, and interesting to see OpenAI venturing into our world of CAD and design tools in 3D. Here's a system for manufacturing advice. You start with an aluminum extrusion cross-section over here, and then the system tells you manufacturing improvement items designed for manufacture. You should eliminate the sharp edge. You should make that wall thicker, and so forth. This I threw in for fun. This is not a modern AI tool. This is from my own master's thesis in 1986. And if you remember, I mentioned that we did some AI work in the 80s because we thought AI was going to be the next big thing, and I actually wrote my thesis on a Lisp machine, if anyone knows what that is. If not, you can Google search that. And I said in the thesis, artificial intelligence programming languages and environments are very valuable tools for developers of CAD software. I was only about 4 decades off in time, and that's the way it is with research sometimes, right? But seriously, the tools I had in that day were completely primitive compared to what's going on today, but I just thought it was fun to show you that. And there's many more potential areas. PDM, industrial design, I mentioned. Anywhere parameters need to be entered, design standards, requirements and specs. It doesn't have to be geometry. It doesn't have to be 3D like I'm talking about. But hey, that's where I spend my day job is 3D, so that's what I think about, But there's a lot of design help that can be done that doesn't involve the hard problems of geometry, and those can be as much or more valuable to the product developers of the world. Geometric search is another big area that I didn't cover. So that's my quick tour of a bunch of different research, and I only scratched the surface, but I hope you're inspired a bit by the breadth of what people are thinking about. I asked a professor friend, I said, who knows everything about AI and product development these days? And they said to me, nobody. There's too much going on, and it all changes every day. Maybe someone in this audience knows everything, but I haven't met anyone yet who knows everything. So, I want to turn to another subject. What do I think should be on our minds as the people who do research and build tools? I'm a tool builder. Some of you are tool builders too, right, in your research. It's part of what you do. Some just do research on process or whatever. What should be on our minds? Well, one thing that's on my mind is, can we evolve the AI tools and technologies to go from working on text and images to working on 3D geometry? Okay, and relationships between parts. Can we bring that AI power to our world? Okay, our world, I say, the CAD type geometry of product development. And conversely, can we bring the geometry of product development more into the world of text and images, like some of the examples I showed you? I think both are important to think about. They're both valid, they both work, we need to think about both. AI errors, this is a really important one. You're probably aware of it, but I want to bring it more to the forefront of your thinking. We now have a new class of what I'll call AI novel errors that we didn't have to worry about before, like hallucinations and data training bias. Your AI is only as good as your training data. We all kind of intellectually know this from reading in the media about, more general AI, but it's present in our world too of product development. So we have to be aware of biases and indeed errors. And errors can be a particularly nasty thing when they involve physical mistakes in products, okay, as opposed to just, hey, the image is wrong or the text is wrong. If parts are made and they're unsafe, that's a problem. We need to iterate AI tools fast. Okay, this isn't so much a research topic, a little bit, but for us in the industry, it's a big topic. CAD and PDM is traditionally released about once a year, right? Yeah, I got news for you. We're not going to get there with 10 releases in the next decade, We need to iterate super fast because no one knows what these tools are ultimately going to be doing anyway when we ship it. Now, for those of us at Onshape, if you're an Onshape user, you're in luck because we release every 3 weeks. Okay, a little plug from our sponsor, here. But no, seriously, we put our money where our mouth is, so to speak. These tools are going to require super fast iteration. Same with you in research. Don't get too far along on that PhD project before you get out and test some of it, because this is all new frontiers. Hyper agility is called for. This is really important to me. I say mind the gap between demos and reality, okay? It's great when you do a project and you show an example like this one, and that's a totally appropriate and valuable thing to do, but don't confuse that with what's done in the real world, which are things like this. Okay? The real world is more complicated, and eventually the tech has to get there in order for it to be valuable. Okay? We can't sell a CAD product that makes objects like this. We need to make objects like this. Speaking of that, this is a Onshape customer, Ocado, and this is their 600 series grocery robot. Another YouTube video you can watch. It's an amazing video. Just punch in Ocado 600. The topic I want to talk about is multiple 3D modeling methods, okay? Implicit, lattice, voxel, point cloud, these are all growing in usage, and you saw it in the research, right? It's not just because of AI, it's because of generative design and 3D printing. We need to better mix old and new geometry models into cohesive systems and processes. Okay, we need smooth workflows for users. We can't tell users, well, export your point cloud and run it through a converter that makes a mesh, and then run that through another converter that makes this crummy NURBS model that barely holds together, and then import it into CAD. Oh wait, you want to iterate? Well, you got to go back and do all that again. That's not going to cut it. We need to think about geometry. I think the future is mixed. I don't think one representation will win out. I think we have to think about all of them working together. And this product illustrates that, because this is the only product I know that has, it's a shipping product. It's a grocery warehouse robot, by the way, about the size of R2-D2. It has hundreds of generative designed, meshed or implicit modeled parts, combined with precise B-rep surfaces, for those of you who know what I mean, precise surfacing, because it's a machine and it needs precise surfaces. Okay, and now a word from our sponsor, so to speak. No, because I think it's relevant. I think Onshape's a great tool for AI research, and I just wanted to offer that as another consideration for you. Okay, and I'll tell you why I believe this. First off, we're already being used widely in research. Anyone doing a research project and using Onshape or Onshape data as part of it? Few people, okay. We have a lot of research papers that are referencing Onshape. We have a free plan. We have several different free plans for education. So it's very easy to access. There's nothing to install or download, by the way. And we run, I don't know if I mentioned, we run on any kind of computer you have. Windows, Mac, Linux computers, no problem. An old Linux computer, no problem. Don't have a computer, no problem. We'll run on your tablet, your iPad. Don't have an iPad, we'll run on your Android tablet. Don't have any of that, we'll run on your phone. And if you don't have a phone, well, I don't know what we need to do with you. So the point is we run on anything. And we have an unbelievable collaboration. And I want to take a moment and introduce, we're proud to be sponsoring here. I want to introduce two of my colleagues, Bernard and Kirian, here in the front row. Will you guys stand up? They're manning the table out front. And you have a rare chance to talk face-to-face with them here because they are experts in using Onshape in education. That's all you do, right? The two of them only work with educators. Okay? Now, most of the Onshape business that I'm not talking about, most of our team and our business is about selling to commercial companies. We have thousands of companies using Onshape to design everything from, wristwatches to aircraft and, thousands of things. But Bernard and Kirian don't do that. They're focused on serving you. So this is a great chance to talk to them. They're at the table out front in the lobby. All right, great AI starts with great data. Remember I mentioned the 5 million sketches? Where are you going to get those? The Onshape public model library. I don't know if you realize this. We have online in the cloud over 10 million public open source licensed CAD documents. Some of these documents have huge models in them. Okay, by the way, I think it's closer to 20 million now. I say more than 10, but it's probably 20 million. This is a really, really good data source for you. And these are created by our free plan users. We have a free plan not for education, for makers and open source people that have made these. You can export them, you can access and manipulate them via a REST API. We already have some major AI data sets published based on Onshape data. Any of you know the ABC data set? That's sort of popular out there. That's based on Onshape data. If you're interested in making a data set for training, first, see if one already exists, and if it doesn't, talk to us. We can help you. If you're going to do something large scale, speak with us first. I'm not sure Bernard and Kieran are ultimately the people, but they can get you in touch with the right people. Matt on our team or someone like that. We have a whole team of people, and they've been through this. They can help you get the best experience out of creating your data set. Don't go calling our API 28 million times before you've had some assistance with how to do that well, okay? Speaking of our API, it's a great research tool because we have the whole CAD system and PDM system available through a REST API. I think we're about the only ones that do that, because when our end users use Onshape, all the traffic is going through web APIs. We don't have an installed app. So you really get access to everything. Finally, we also have this unique language called FeatureScript. Anyone heard of this? This lets you create features of your own. FeatureScript is used by us to write our own features like extrude, fillet, shell, loft, sweep, those building blocks. In other CAD systems, those are hard-coded, but in our system, they're written in an open language called FeatureScript, and we give you that code, open source, for you to modify. You can create your own features. You can create a CAD system in a CAD system. This is valuable for certain types of AI projects. You can think about that, and again, you could see that, right? Bernard and Kieran could show you this. And then mixed modeling. I spoke earlier about mixing modeling representations. Here's an example of an object in Onshape where you can have mesh parts, you can have precise parts, and you can also have parts that are a mixture of mesh and precise geometry. And they all work with the same set of modeling tools. There's no mode, there's no conversion. So this part here, the orange faces are mesh, the gray faces are precise. Again, some of you, if you're working with geometry, this is a very cool thing. If you're not, it's not for you, but I mention it because it's really powerful. It takes away a lot of the need for all that messy conversion stuff. Finally, Onshape is also PDM. We have revisioning and versioning. We have branching and merging like GitHub, if you've used that, okay? And a complete history of every edit that's ever been made. Who did it and when. This is great data. I know some researchers are using it at different universities around the world. Great data. Someone here was talking about using our data. Tremendous amount of data for you. So with that, I want to close with a huge thank you. I've listed a small number of the people here who have educated me on AI and helped me think my way through this world. And I really do want to say a big thank you to the entire worldwide research community, because it's research that brought us where we are with the state of the art in CAD tools, as I showed you. And I think research is more important than ever in this AI world. I think it's going to be from you that we find great ideas, not necessarily inside the companies in our industry. And I'll close with my predictions about AI. First, I think AI tools will become widely used and valued in product design, period. I think that it will augment the human engineer, not replace them, which I hope we all believe. And I think the applications are not just, hey, computer, go design a product, but rather in things like simulation and CAM and drawings and so forth. I think AI is going to become so obviously and widely used, it's going to be the way computers or the internet or Google search became. That at one point in time, they were these incredible things we were noodling over how to use, and now they're just givens. Everyone uses it. We don't talk about it as much anymore, right? I think that's what's going to happen with AI. It's because I believe in it so much. I think that AI is going to give every product designer the capability to be like Iron Man. So with that, thank you very much, and we have time for questions, right?
Thank you very much for really inspiring speech and presentation. I personally enjoyed it. I believe a whole audience enjoyed it. So I would like to open the floor for questions. So are there any questions from the audience? Yes, please. Wait for Mike, sorry.
Thank you very much for the inspiring talk. My name is Harald Schaub, University of Bamberg in Germany. I have a more provocative question. Do we ever have really AI tools for product development? The background of my question is, when we have AI tools which are really operating in day-to-day use, we don't call it AI, like navigation systems, like all the algorithm we have in our smartphones, so it's only AI until it becomes productive. Is it only a wording or something more serious behind that development?
So is the question, well, first off, you're right. AI is being used like language translation, I believe, is all now changed to using AI-based methods. And is your question, is it just work or theory? I don't know for sure. I think it's going to take more of both. I think some things like simulation surrogates are well on the way. The image-based design products, those are well on the way. I think just work, those will yield to work without seemingly more theory, to the extent they do things. I think things like meaningful geometry generation is going to take more thinking about theory than extrapolation of the tools I've shown. But it's going to vary by area. But that is a great point. It's so obvious we're already using it. Yeah.
Professor Giro?
Thank you for a fascinating talk. You said something which I didn't expect, because the current AI world does something which apparently you don't. And that's your open source data. You're generating that through your users. Is that a requirement of a user, that their models be open source? In other words, where is the source of the open source models?
That's a fantastic question. Let me explain. The first is absolutely not. There's absolutely no requirement that people be open source. Most Onshape users' data is completely, thoroughly private. So private, I mean, certainly we can't see it. You know, it's very, very, we have among our customers some of the highest security organizations in the world, I'll just say, and they thoroughly vet our security. The public data I'm talking about comes from an open source community where we offer a free plan. So we have an Onshape plan for open source projects. And that plan only requires you to have, the deal we say is you can use our CAD for free, but your work is open source. And that's where that model library came from. Okay, we also use that library for QA purposes, for our quality of our own software. We can run massive amounts of QA against that open source data in ways we can't do necessarily with customer data. So it's completely segregated. You know, most of our business has nothing to do with that. There's this public data repository from the open source plan. By the way, the education data is not open source. Like if you get our education plan and you and your students use it, it's private data. But we built up this public data set because we kind of knew it would be valuable for what we then thought of as machine learning. We didn't anticipate everything with AI. And so, yeah.
Can I just ask a supplementary question? For you to, can I just ask, you mentioned that of course the AI is only as good as the data. And now we have a biased set of data.
Yeah.
And I'm just wondering what the implications of that might be, because clearly the sort of data that people who are using the free version is probably not going to be as rich as the people who are doing more serious work. And I'm just expressing a concern which you expressed, but now it's in your data as well.
Yeah, so a couple things there. First of all, you should be concerned in any data set with bias. I mean, if we go to if one of our customers said, here's all our private data we want to contribute to the community, that will have biases in it. But you said something that I think I'll challenge you on. You said, what about things that are more complex than open source? Don't make the error of thinking open source means simple, because as Linux has shown, and many AI tools have shown, a lot of our models in the open source library are extremely complicated and sophisticated and exceed in some ways what we see in professional work at times. So yes, on average it might be simpler, but there's a lot of complexity and richness in that data. But it's up to you. Like, I don't know how to express the biases. That's where we need your help, and people need to think about this as a topic of how to think about and categorize and consider the biases in training data for our field of design.
Thank you so much for the talk. Kind of related to the same question. So when you have all of these different data points in the data set, do you think that it's possible to somehow quantify a good design? And how do you ensure that the data set is all good design and also has the safety that's required when someone's designing something super important with it? Do you think there's going to be an ecosystem of tools that'll rise around it to ensure it's, safe enough?
It's a great question. To some degree, all the projects that I mentioned in data sets involve some amount of culling, evaluation, and saying which types of models are most useful to the data set we're building. And some of that might define what's good, but good would mean in a particular domain. A particular set of goals. What's good for one thing may not be good for another. So again, we're back to bias and makeup of the training data. But yeah, our data set, being as large as it is, would be pretty well suited for coming up with ways that you might categorize. And again, this is an area you could talk to our team who's had some experience in working with people to do this. But at least we have some data to start with. And that's valuable. But this is going to be a journey we're on, for sure. And okay, and there was you had an answer.
Yep.
Right, Martin. Were you going to answer, or you just? Oh, you had a question. Okay.
I would like to have an answer, Jon. Thanks for the presentation. But I'm a little bit curious. What is your belief? Where's the border between human intelligence and artificial intelligence? So we worked. For example, you showed generative geometry. I worked together with anthropology. They did the same. They built up a software mix from computer-aided engineering and computer-aided design with some intelligence, but it was programmed from humans. At the end, we got something a human is not able to design. A prepared geometry for 3D printing. But the system is not learning. So for me, it's only human intelligence and not artificial intelligence. What is the border? So for me, artificial intelligence should learn. So it should extend. We feed the system, and then it must do more what we have fed it. And so I have survived 3 types of artificial intelligence in my life. The first was decision tables, and it was really stupid. Yeah? So what is your opinion?
Well, wait, I'm sorry. What's the question exactly? Is it?
It's a question. Where's the border between human intelligence and artificial intelligence?
Where's the border between the two? I don't know. I mean, I think, like I said, these are going to be augmentation tools to the human, like computers have always been. I think we're going to get closer to fulfilling the aided in computer-aided design. I think AI is going to take us. The aided starts with AI. There's a little phrase for us, in computer-aided design, that will rise. It's really about bringing us to higher and higher levels of assistance, so that ultimately, the ultimate goal that we all have in common is we're trying to enable the product developers of the world to do a better job, to produce a better product, to do it faster, to be more innovative, to have more fun, to save money and time, or whatever. Something, a higher performing product. And I think that if we're doing that, it's a partnership. And and by the way, all this code is written by humans. So I don't know. These are questions we have to go down the hall of the philosophy department maybe. But for us, build great tools and it'll help the human designer, I think.
Thank you very much. See, I believe that we are slightly behind the schedule, and since coffee, I believe, is waiting, so I would like to thank once again to our speaker, Mr. Hirschtick. Thank you all for being here, and see you later. I hope you'll enjoy the rest of the conference.